Hi and welcome to this video where I'm going to be taking a look at one of these, which is a fuel pressure gauge. And the usefulness of this is your manual will state what the pressure should be on the fuel rail. And in example, this car, it should be 3 bar or 43 psi. On the Cooper S, it should be 3.5 bar and 50 psi. Now, if it's not meeting that pressure, or it's too high or too low, it can be many things. It could be a clogged filter on the fuel pump in the tank. It could be the fuel pump that's starting to sort of pack up. You could have kinked flow and return fuel lines because the fuel is pumped up to the fuel rail. The pressure regulator then controls that pressure and maintains it under all driving conditions, and then it's sent back to the fuel tank. So if any of those lines are kinked or blocked or anything like that, then you're going to get an adjustment in the fuel pressure. So this is a useful test to find any of that out and check it. Now what I'll also do is a flow test where I'm going to pull the fuel relay out and connect a switch straight in there, and then I could just press the trigger, time it and see how much fuel flows and how long it takes. So I'm going to do that test, and then just to finish the video I'm going to take a relay and show how the relay actually works and open it up so that we can see inside the relay. So that's basically this video. Next week's video hopefully will be about the fuel pumps, because I plan to open the tank and we'll have a look at the fuel pumps and the sender unit and stuff like that. So, but this video is on the fuel pressure, and hopefully you'll enjoy it, and many thanks for watching. So we'll have a quick look at the set and what's in it. So it's quite comprehensive. Right then, so ensure the test vehicle has plenty of petrol and have a Class B fire extinguisher to hand like foam, powder or CO2. So what I'll do now is just make sure we've got plenty of fuel in the car, because the last two occasions I've run out of fuel on both attempts when I've been doing some testing. So make sure we've got that, and definitely some sort of fire extinguisher when you're playing around with petrol. Okay, now then, so next task is to depressurize the fuel rail so when we tap into it we don't spray petrol everywhere or into our eyes. So I have a couple of photos here showing where the fuel rail cover is and the fuel pipe as well. And then once that cover's removed, we can actually see the fuel rail, which is underneath, and there's the fuel pressure regulator and the fuel rail in yellow. And this is the dust cap that we need to remove on the end to connect our gauge. And there's our quick pipe connector on the fuel rail. Right then, so first job is to remove the fuse. So on the Mini it's just in here. That's all the fuses, and it's fuse 20, and you'd normally use a little plastic tool that should be supplied with the fuse box, and I haven't got one to hand. So anyway, so that's the 20 amp fuse removed. So if we now start the engine, that should depressurize the system because the fuel pump's not going to be running. There we go. So it died quite quick. Just check that. Right, so that's it. We've got no petrol. So it should be safe to now start removing stuff on the fuel system. So we just remove the cover here. So there's a couple of little tabs there, and then it pops on with some clips underneath onto the fuel rail. So we'll just pull that away. We'll have a quick look at that so we can just see all the parts there are. We'll go back again and take a closer look so we can see everything. Right then, so now to connect the fuel pressure gauge. Okay then, so we just need to remove that little dust cap on the end. Try not to lose that. Putting it there is probably not the best place. And then what we need is the adapter to fit on this particular fuel rail. So for my Mini, it's this one here, which has got like the Schrader valve on the end, like so. So we can now just screw that on in place. So if we hadn't depressurized it, at this point we would actually have petrol start leaking out under some pressure. So that's the reason for depressurizing the system. So it's a lot safer to do that. Right, so we've got our adapter in place. We just pop this connector back in. And then we can connect the gauge now. So we actually have a drain pipe on the gauge as well, which is the clear pipe. And there's a little push-in spring valve there to relieve the pressure. So that clear pipe I'll put into a container. So this is a quick connector, which is quite handy. Pop that on like that. And then we can hang our gauge up, like so. Put this end into a jug. Ideally that would be on the floor in case it fell over. Well, we pop it there for the moment. So what we need to do is put our fuse number 20, which is 20 amp, back in now for the fuel pump, so that we can actually start the test. Okay then, so test 1 of 2. Okay, so I need 43 psi, or about 3 bar. We've gone shooting past that up to 50 psi. And that looks alright. So I have 42 psi, or about 2.9 bar. Now the only thing was the engine was starting to stall for some reason. Not quite sure why. Perhaps some air was in the system. So I didn't feel this was quite accurate enough for the test. So I was wondering whether air was actually in the gauge line that was allowing it to be sort of pressurized, because obviously air is compressible. It's still holding there at the pressure. Like I said, the engine's not running too well though. So I think what I'll do is try the test again and just see if I press the valve whether any air will come out, just in case there's some air trapped in that test gauge. Right, so we'll depressurize the gauge like so, and then we'll run test 2, I think. Right then, see what we get this time. So there's our pressure, straight up to 50. So the engine's actually running okay at the moment, but I'll still just press this valve in, which will sort of let any air out of the gauge pipe, just in case it was that. Roll that out. Might have been just the fuel in the main pipe going to the fuel rail. So anyway, so everything looks okay. So like I say, the Cooper is supposed to be about 3 bar. So we are dropping a little bit there when I rev. I'm not sure if it's actually supposed to do that, because I presumed it was supposed to actually maintain fuel pressure over the whole rev range. But what I can say is that when this car was on the road, it never had an issue with acceleration, so unsure on that one. Maybe somebody can add something in the comments. Right then, so the fuel pressure shouldn't drop with the engine switched off. Ideally leave the tester for 30 minutes to see if it drops. If it does drop, that could indicate a leak somewhere in the system. Okay, so fuel pressure diagnosis. The fuel is pumped to the fuel rail / pressure regulator and onto the injectors. Any excess fuel is returned back to the tank. The fuel pressure regulator should maintain fuel pressure over all engine loads, including harsh acceleration or deceleration. High fuel pressure can be caused by a faulty regulator, a blocked return pipe or kinked flexible pipe in the tank, or excess tank pressure due to a vent fault. Low fuel pressure can be a blocked fuel filter, restricted supply pipe, faulty fuel pump, faulty pressure regulator, or a vacuum forming in the fuel tank due to a venting fault. So I've left the gauge for a while and it maintains pressure, so that's a good sign. Okay, so we can now remove all this. Just trying to make sure that's all clear. A little bit of petrol will come out of the pipes, so you might want to just be wary of that. So we can now carefully unscrew the adapter, like so. Again, petrol will drip. And then carefully put the plastic cap on. And then make sure you reconnect that electrical connector, like so. Okay then, so we'll take this and empty that back into a fuel can. Right then, now for the flow test, which is also a very quick way to empty a fuel tank if ever you needed to. So what I'm going to do here is remove the fuel pump relay, so which is the bottom one. So effectively what we'll do is short pins 30 and 87. So that's basically what the relay does. Well, what we're going to do is use a remote control. So this way I'm actually at the front of the car, so I can immediately stop the fuel pump if I need to. So again, we just pop this cover off. We pull the relay out. So this is the fuel pump relay. And then we just connect the connectors of the remote switch into pin 87 and pin 30. So should I just take this round now to the front of the car? This is actually a winch controller, that is, which has been adapted, and this has also been adapted, as this is a quick release connector where I've put a pipe on the end. So to remove the fuel pipe, the quick connector, we just need to push the black part in like so, and it would just pop off. And if you see these two exactly the same, I'll just show those next to each other. And then that should just push in and lock on. Make sure the black springs back. There we are. That's locked on. I'll just pop a bit of tissue under that so I can immediately see if that's leaking while I do the test. So I've got my can ready. I'll set my phone. So the timer's running on that now. We've just got to subtract that time from when I press the button. And here goes. So I'll speed this up. So 1 litre has taken 24 seconds. We've got 13 seconds there we need to delete. And then if we shoot this ahead to the full 5 litres, nearly there, that's our 3 litres now. There we are, just coming up to 5 litres. And what's our time there? So 5 litres has taken 120 seconds, and if we do an average on that by dividing it by 5, we still get 24 seconds. So to empty the whole fuel tank of 50 litres, should be able to do that in about 20 minutes. Right then, so we'll pop this now back into the container, because I actually need this fuel tank empty for next week's video. So I think what I'll do now is a final draining of the tank with the fuel pump audio only, so you can actually hear the fuel pump when it actually runs dry. So there it's pumping away. Now it's starting to get air. You can hear it trying to suck. There we go. You can hear the revs increase. So that's empty. So you wouldn't want to keep doing that, otherwise you will mess your pump up. Right then. So now to reconnect the fuel pipe, the plastic cover, and replace the relay, and ensure no leaks when starting the engine. So thankfully nothing did leak here. So we just pop the black plastic clips back in like that. Make sure you drain that pipe into a suitable container, and then you just got to push that back on to where the fuel regulator is. Alright, try and mop some of that petrol up. Again, then we just pop the cover back on. So there's two circular clips that clip onto the fuel rail underneath, and then it just pushes in on those two clips on the top like that. And then we can go back in the car, remove our leads. So take that one off and that one, then pop our relay back in there. Just showing you the bottom there. So I'll include photographs on that, or possibly might go into it and show a bit more detail on the relay. Okay, so how the relay works. A relay is basically an electromagnetic switch. Using low power we can activate the relay, which can then switch on heavier power loads. The starter motor requires huge cables to carry the loading required, but we need discrete and thin wiring at our ignition switch. So if we take a closer look at this relay and we'll see how it works. So what we do is we add some wires here to a power supply so that we can energize that coil that's inside. And it's that coil that switches on the contacts to the fuel pump. Right then, so that connected, we set our power supply to 12 volts, which is the same as a car. And we should be able to hear the clicking as we energise it. I'll put a microphone there so you can hear it a little bit clearer. So that's the electromagnetic coil working. And then if we add our separate circuit, we'll mimic this, pretending it's our fuel pump. It's actually a light bulb, but think of it as a pump. So when we turn our ignition on, it then sends the power to the fuel pump, like so. Yeah. Okay. So what we're doing now is we're open this up and see if we can have a little look inside. So that's inside the relay. So we've got a coil of wire there, which is the electromagnet. So as we energise that, the little contact plate at the end will be pulled towards the magnet, which holds the connection pads. and then that will make the connection between pin 30 and 87. So this one also contains a little resistor in parallel to that coil, and the job of that is, as you turn the power off to it, you'll actually get a spike of electricity as the magnetic field collapses, and that could cause a spike in the circuit. So they often use a resistor or a diode to neutralize that. Anyway, so that's basically how a relay works. So on to reference photographs, which you can pause to view for longer. So here we are under the bonnet with the fuel rail cover, and there's with the fuel rail cover removed, you can see the vapor pipe there in green. There's our fuel pressure regulator in turquoise, and our little end cap there. There's also the vacuum pipe there going to the regulator, and our quick connection for the fuel pipe. And then we just go inside the car. So this is the cover for the fuse box. There's our fuse number 20 and our fuel pump relay. Another photo showing that. And these are all the different fuses in that fuse box. And here's the connections for the relay. And this is the pressure test kit that I used. And here's a close-up of that relay, showing the diagram on the side of it. With you can see the resistor there. There's our pin numbers, and there's that inside of the relay. So you've been watching fuel pressure test and inside a relay on a MINI R50. And thank you for watching, and I hope this video helps you service and maintain your car within your budget. This video was filmed and edited by me, Mark Savage, in February 2022, and I can be found on Instagram and Facebook as Coats and Gators.